Okay, so now we're doing lesson 3 of module 1, and we're doing monomials. And hopefully you have gone through the explore part and on the computer in the program, because this is a really good one for you to go through. I am not going through it here. So, power of a power. So remember, if I have this right here, this is a power. I shouldn't have done that. I have a new, this is a new way to, maybe this, okay. This whole thing is the power. Okay, so now it's saying, I'm going to take this whole thing and put another power on it. That's what it's talking about. So if you look here, you have a set of parentheses. You have one exponent, two exponents. So it's talking about that. What does this mean? Well, what this means is that I have 6 to the 4th, which is this right here, and all of that is written to the 3rd power. So I have 3 times I'm writing 6 to the 4th. And we learned in the last unit that if I have multiplication of the same base, 6, 6, and 6, that I add the exponent. So that is going to get me 6 to the 12th. Okay? Now, if you look at this, this is brand new setup, guys. If you look at this, 4 times 3 would get you the 12. That is called the power of a power property. You can simplify a power raised to another power using this. And all you do is you multiply exponents. So down here, I have a power raised to a power. So I multiply the exponents and I get 5 to the 6th. Having a hard time. There we go. Now, if I look at this one, we know the base is the same because there's only one base. So now I'm looking at my exponents. I have a power raised to a power, so I multiply those powers together and I get 8 to the 18. Here, again. Now I'm going to show it in an expanded form really quick. So 6 to the 3rd raised to the 5th. So that really means that I have 6 to the 3rd times 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 6 to the 3rd. Okay? So I have 15 of those. Okay? So all they're teaching you is the property. And the property says that you multiply these two together and you would get the 15. Okay, now it's the same thing except for our base this time is a variable and not a number. Sorry. I multiply these two numbers together and I get 35. Again, there's only one base, so I write the one base down. Then I look at the two exponents and I multiply them together and I get 28. Now, sometimes though, we have two bases inside. Remember, there's an invisible 1 right here. Just want to make sure you understand that. So, inside the parentheses, we have 4a squared, 4a squared, 4a squared, because it said to write it out 3 times. I look right here, I have 3 4s, and I have 3a squareds. So 4 to the 3rd power is 64. I multiply these two exponents, and I get 6. So it's 64a to the 6th. Notice that each factor inside the parentheses is raised to the outside power. I don't know. Okay. So remember, I'm splitting up the 2 factors. I've got the 2 factors. They're both raised to the 4th power. There's an invisible 1 here. I multiply 1 times 4, 3 times 4. I get 2 to the 4th, x to the 12th. 16x to the 12th. Okay, so let's try it again. So again, when I look at this, I have a factor here and I have a factor here. So we're going to split apart the factors. I have 2 raised to the 4th power times p to the 3rd raised to the 4th power. Okay, so I have 2 to the 4th, which is 16. Then I multiply these 2 exponents together, multiply them together, and I get p to the 12th. So here we go. I'm going to rewrite this as the 2 factors. So 7 raised to the 3rd power, w to the 7th raised to the 3rd power. Remember, there's an invisible 1 right there. So 7, 1 times 3, w, 7 times 3. So I have 7 to the 3rd power, w to the 21st power. Oh, it wants us to multiply it out. Well, it's going to come out to be this one. Okay, next. Okay, so again, this time around we have more than 2. I have the first one here, the second one, and the third one. So we're going to split them up. They split them up. Negative 2 to the 5th power. Negative 2 times negative 2 times negative 2 times negative 2 times negative 2. Remember, these 2 are going to make 4. These 2 are going to make 4. Then I have just a negative 2. So my answer is going to have a negative on it. 4 times 4 is 16 times negative 2, which is negative 32. Then right here, I multiply my exponents. I multiply my exponents. And then I will end up with negative 32, m to the 35th, n to the 30th. Okay, again, I'm going to split these up. So my first, second, and third. So negative 5 raised to the 3rd power, w squared raised to the 3rd power, z to the 8th raised to the 3rd power. So negative 5 times negative 5 times negative 5. We have w 2 times 3, z 8 times 3. This will get me negative 125, w to the 6th, z to the 24th. Okay. 6 right there, sorry. Okay, next. A square floor. It's not really a square, but we're going to pretend it's a square. Has a side length of 8x to the third y squared. Square tile has the side length of a square tile has the side length of xy units. How many tiles will it take to cover the floor? Okay, so has a side length of this, so that means that this right here is that. So we probably ought to find the area of that. So also, the area is equal to side squared. So if I'm looking at that, I'm going to take 8x to the third y squared, and I'm going to square it. And I'm going to take that down here just because I have more space. I'm going to square it. So I get 8 squared, x to the third squared, y squared. When I do that, 8 squared is 64. This would get me 6, and this would get me 4. A square tile has side length of xy units. So the little tiny square that goes inside has xy. Oh. If I want to, if I want to find the area of that, I would get xy all squared. When I do that, I would get, where am I going to write this? X squared times y squared. So that's going to get me x squared, y squared. So I need to know how many tiles it's going to take me to get that on the inside of that. How many tiles is it going to take me to get onto the inside of that? So if I was to take this, I would want the area of the whole floor divided by the area of the tile. So the whole floor was 64 x to the 6th, y to the 4th over x squared, y squared. Now we learned this in the last chapter, or the last lesson. So I'm going to line them up. 64 is by itself. Then I have these two over each other, these two over each other, and I'm going to divide that. So I subtract my exponent. So I get 64. I subtract my, trying to give away the answer. So 64 x to the 4th y squared. And that is how many tiles we will need. Okay? The floor of the commons room at King Middle School is in the shape of a square with side length 3x squared y to the 3rd feet. New tile is going in to be put into the floor, and the square tile is xy feet. So we're doing the exact same thing. So I need the area of the whole thing, which is side squared, So I'm going to take the side, which is 3x squared y to the third, and I'm going to square it. When I do that, I get 3 squared times x squared, all squared, y to the third, all squared. And I'm going to get 9x to the fourth, y to the sixth. Over here, for this small tile, I'm going to get xy and all of that squared. So remember, I need to separate it, so that's x squared times y squared. Then I'm going to take the area of the whole class divided by the area of the tile. I'll write that over here. So 9x to the fourth, y to the sixth, divided by x squared, y squared. Again, the 9 is going to stay where it is. The x's line up, and we subtract the exponents. 4 minus 2. The y's line up, and I subtract their exponents. So it's going to be 9x squared, y to the fourth. Oh, I don't need feet. They cancel out. There we go.